talking about when we're getting going here. So synthetic division is a way to divide polynomials. Back in Algebra 1, you divided polynomials using long division. So maybe you had like a x plus 1, and then underneath your radical you had your x squared plus 2x plus 1, and then you went ahead and used long division to divide that out. Well, we're going to learn a new way, and it's a much easier way and a much quicker way to divide polynomials, and it's called synthetic division. Now, before we get into synthetic division, we're just going to talk a little bit about how division works, and then what we are going to use it for with these polynomials. So if you look at just a very basic division problem, 15 divided by 3. If I take 15 divided by 3, I'm going to get 5. 15 is called your dividend. And then 3 is called your divisor. And then 5 is called your quotient. And I think I spelled quotient wrong. Don't worry about that. But your division problem, every division problem has a dividend, and then your divisor, and then it's going to equal to your quotient. Now, the division algorithm for polynomials, what it is saying here, and we got a lot of information. So our p of x, our polynomial, is equal to your divisor times your quotient plus your remainder if possible. So what that's basically saying is if you take your quotient, you multiply it by your divisor, you're going to get back to your dividend. Now what we're going to look for today is we are going to check for this divisor. We're going to check to see if it's a factor. And with polynomials, we are going to start finding factors when we are going into sections 5 and 6 here in just a second. So we'll use synthetic division a lot to check to see if we have a factor of a polynomial. Now we have a factor if your remainder is 0. So anytime a remainder is 0, that means that the divisor is going to be a factor of the polynomial. So like in our case, 15 divided by 3, 3 is a factor because we just get an answer of a quotient of 5 with no remainder. So our remainder is 0. That means that we do have a factor. So when we're practicing and we get to delta math, sometimes we'll have a remainder. That would mean that our problem is not a factor. If we don't have a remainder is 0, then that means it is a factor. So we're going to head to practice this process of synthetic division. So we're going to head down to this problem. So first, we are going to take 5x squared plus 2x minus 3, and we are going to divide it by x plus 1. Mason. If you get a remainder, we're going to write it in remainder form, and I'm going to show you that on delta math here in just a second. So we've got a 5x squared plus 2x minus 3. We're going to divide that by x plus 1. Now, synthetic division is going to use the root of this linear factor. So remember, a linear factor, we would set this equal to 0 to solve it out, and we'd figure out, okay, what makes this linear factor 0? X would have to equal -1. So when you're using synthetic division, you're using the root of that linear factor, x plus 1, so that would be a -1. I just think of it as you're just going to use the opposite of whatever this is. So plus 1, that means I'm going to use a -1 as my root. The next thing is to set up your synthetic division, you're going to make an elongated L. And then the nice thing about synthetic division, different than Algebra 1, is that you do not need any of the variables. All you need are the coefficients. So you take the 5, you look at the sign, this would be a +2. You look at the sign, that would be a -3. So you just take the numbers 5, 2, -3, and then now you can start your division. So we're going to check this x plus 1. We're going to divide it into this polynomial 5x squared plus 2x minus 3, and we're going to get a quotient. So we're going to get an answer, and then the quotient times this x plus 1 will equal back to our polynomial. That's the idea. So synthetic division, how it works. The very first number in your dividend falls down. We bring it down to here. So 5 is going to come down. Really what we're doing is we're adding this column. So 5 plus there's nothing there is just going to be 5. The next thing that you do is just a little bit of arithmetic. You're going to multiply -1 times 5 and then put that number into the next column, which is going to be -5. Then again, you're going to add your column together, which is going to be 2 plus -5, which is -3. And then we repeat that process. You're taking -1 times -3, and that's going to go into the next column, which gives us an answer of 3. And then we add -3 plus 3, which ends up being 0. Once we get to the end, this last piece right here, this represents your remainder. So right there would represent my remainder. So now I've divided x plus 1 into my polynomial 5x squared plus 2x minus 3. The last thing I need to do is rewrite my quotient. My degree is going to lower by 1. Since I started as an x squared, it's going to go down to an x, 5x minus 3. And then my remainder is equal to 0. So there would be my solution. 5x minus 3 is equal to 0. And what that tells me then is the 5x minus 3 times x plus 1, that was my divisor, is going to equal back to that polynomial. So that 5x squared plus 2x minus 3. So we will continue to work on that. That is, it is 10 o'clock, so you are free to go if you want to go off and work on your own. But what I'm going to do next is I'm going to just open up Delta Math, your Delta Math assignment, and I will continue to do example problems in Delta Math so that you can see some more examples, and you can kind of have your Delta Math open if you want to work on some problems as we're working on it. But it is 10 o'clock, so you can break off to go on your own, or if you want to stick around with any questions or work through some problems with Delta Math, you can stick around. All right, so we'll head over to Delta Math next. So in your Delta Math, each day at 7 o'clock a.m., your new assignment for that day will come up. So we'll start with synthetic division. So we'll look at this first problem. We'll talk about how we can put in our answers, and then we'll look at synthetic division level 2. And then we'll take a look a little bit at the remainder theorem. So first, synthetic division level 1. So these will be some easier ones to kind of start off with. So we're going to look at what is the result when x to the 4th minus x to the 3rd plus x squared minus 19x minus 6 is divided by x minus 3. So just a reminder, anytime if you have a question, you can hit the buzzer or you can put something up in the chat and I will see it up there as well. All right, so we're going to set up our synthetic division first. We're going to take the root from our divisor. So x minus 3, I'm just thinking of the opposite of minus 3, which is going to be 3. So I'm going to start by taking that root first of all. And let me rewrite that. I got a little sloppy. I got a new mouse, so it's a little bit harder for me to write. I'm still getting used to it. Next, I'm going to take the coefficients. And remember, anytime you just have a plain x squared, x cubed, that's going to be a 1 in front of there. So we're going to take a 1, then a -1, and then a 1, and then a -19, and then a -6. So there's going to be our polynomial without any of the variables, and now we can start our synthetic division. So first thing, we're going to start with the adding. We're going to add our first column. 1 plus 0 is 1. Next, we're going to multiply our root 3 times that result, and then that's going to go into our next column. So 3 times 1 is 3. Then we'll add, and we'll get 2. Next, we'll go 3 times 2 is 6. Then we'll add and get 7. 3 times 7 is 21. Then we'll add and get 2. 3 times 2 is 6. And now we're at the end. This is going to be our remainder. So our remainder is going to be 0. Now these are the coefficients of your new polynomial. So our polynomial started as an x to the 4th. When I divide that one linear factor out, I'm now at an x to the 3rd. So I have an x to the 3rd polynomial that I'm going to write into my answer here. So I take the 1. I could write the 1 if I wanted to. I don't need to. I'm going to hit x, and then shift 6 will make a exponent. So I got x to the 3rd plus 2x squared plus 7x plus 2. I think since these are level 1, I've done a couple of these, but I haven't had a ton of experience going through all the problems. But I think all of these will have a remainder of 0. So we don't have to worry about writing in the remainder on this one. So here we've got x to the 3rd plus 2x squared plus 7x plus 2. What do you guys think? Does that look okay? Do you guys see any mistakes I made? Look all right? So you will find that if you do make like a little arithmetic mistake here, like maybe right here you put -3 or something, like you just multiplied, it's going to throw off the rest of your problem. So it's good to double, triple check those, just kind of double check your work. All right, now we'll hit submit. Hopefully we get it. And there it is. Then they'll run through it for you so you can kind of see an example. At any time, if you're on your own and you just want some extra help, there's a watch help video right here that'll walk through a problem for you. And they're anywhere from 2 minutes to 5 minutes, and you can watch as much as you need. All right, so that section, I believe you'll get remainders of 0. Let's just try looking at this next one. So next one, I've got looks like an x plus 2. So I'm going to take and use the root of -2. Then I'm going to set up my synthetic division. Looks like I'm going to have a 1, -1, -9, -15, and a -18. Drop down the 1, -2. Add together, you get -3. 6, -3. Multiply two negatives, it gets a +6. And that's going to give me then -9. -2 times -9 is 18. Yes, so it looks like these are going to give you those remainders of 0. So that first section, if you're not getting a remainder of 0, that's kind of a self-check to see, okay, I must maybe made a little arithmetic error somewhere. And then you can go back and check that out. So again, if you have any thoughts, questions, comments, throw them into the chat. Otherwise, I will move on to writing the remainders. So in our next section of Delta Math, we'll practice our synthetic division again, but now we're going to start practicing how we write our remainder. So a couple of things to take note of here. So what is the result of 3x to the 4th plus 10x to the 3rd plus 9x squared plus 7x plus 13 divided by x plus 2? So we'll use that root of -2 divided into that polynomial. If there is a remainder, express the result in the form q of x. So that's our quotient. That's our quotient plus the remainder over, this would be this b of x would represent your divisor. So that b of x is going to represent that x plus 2. So we're going to represent our remainder as a fraction over our divisor. So when you first learned long division, you learned how to write your remainder as a fraction with your divisor. Now we're just doing it with, or sometimes you maybe did it as a decimal, but now we're just going to do it with this divisor of x plus 2. So let's get our problem set up, and then I'll show you what that looks like. So we've got a -2 as our root. Now we've got a 3, 10, a 9. Oh, they're all positive. Nice. 7, and 13. So that's kind of nice. They're all positive. Don't have to worry too much. The biggest mistake that happens is your root. You got to remember that it needs to change to its opposite. So it's always going to be the value for x that would make your polynomial equal to 0. So x plus 2, set it equal to 0. That's going to be the number you divide by. So now we're ready to start our synthetic division. We'll drop down the 3. Makes -6. 10 and -6 are going to combine to make 4. That's going to multiply to make -8. Add those together, you're going to get 1. -2 times 1 is -2. Add that together, you're going to get +5, and then we're going to get -10, which gives us now a remainder of 3. So this time we did not get a remainder of 0, but that is still my remainder because that's the last part of my synthetic division. So that represents my remainder. Now we're ready to start writing our polynomial. So we divided out that factor of x plus 2. So now it's going to go down 1 degree. So we're going to have 3x to the third plus 4x squared plus x plus 5 plus 3, there's my remainder, over my divisor, x plus 1. So this piece right here would be representing my remainder. So that's going to be writing that remainder over the quotient. So now we'll head in to type that in. We'll head in 3x, hit shift 6 to get your exponent. Plus 4x squared plus x plus 5 plus, here we're going to have 3. The fraction button is the backslash, which is right next to shift, over x plus 1. So there would be our result. I'm just going to double check. I dropped down the 3. Okay, that looks good. Because if you make one little simple mistake, it's going to throw off the whole problem. But otherwise, if you remember back from Algebra 1, it's way, way quicker. I know I'm going kind of slow because it takes me a while to type this out, but it goes way quicker than using that long division method. All right, 13. Okay, this should be it. So we'll check, hopefully. Oops, I see I made a mistake. X plus 2 right there. Otherwise, I think we're good. All right, so that would be our result. So there's your remainder going in over the divisor. And if you do get one wrong, you'll get multiple attempts at it, and you just need to get 2 correct to pass that section. So I'm going to just take a pause right there quick and see, is there any questions about that one? Throw them up in the comments, and if at any time you want to interrupt me, no worries. All right. Lastly, then we'll look at the remainder theorem. So we'll go to that last section. Remainder theorem. So in this section, the remainder theorem, we just want to figure out, well, what is that remainder? And here we have 4x squared minus x minus 3 is the polynomial we're dealing with. And then we're going to divide it by x minus 3, which is a root of 3. So we're going to be dividing it by a 3 is when we set up our synthetic division. Sometimes with the way polynomials are written, you may see with the remainder theorem f of 3. Well, this 3 right here, this function of 3, that represents your root. So x minus 3, f of 3, that's going to represent that root. That just means that whatever number's in this f of x here, if it's a 3, 4, whatever it is, that is going to be the root that we use when we do our long division or synthetic division. But now it's back to more of the same. So we got a 4, we got a -1, we got a -3. Drop down my 4, then I get 12. Drop down, I get a sorry, that's going to be a positive 11. So that's going to be 11. And then 3 times 11 is 33. Add those together, we're going to get 30. So that would represent my remainder. So double check my work. 4 comes down. 3 times 4 is 12. That makes 11. 3 times 11 is 33. That's going to make 30. So remainder goes in, 30. That's going to be then our solution. So the only thing they want there is our remainder of 30. So a couple of those to practice with. So the next one, you'll see some more of the same. I wanted to go over this one. So this one is exactly what I wanted to see, but I hadn't seen it yet. So here's the first time we get to our polynomial, and you should notice, so we start at an x to the sixth, and then we go to x to the third, and then we go to a constant. When using our synthetic division, it's still going to be using a 1 as our root. And then we start writing our coefficients. We got a 4 as our x to the sixth. Now there is no x to the fifth in our problem, but we still need to account. There could be a 0x to the fifth, a 0 term in that polynomial. So we still need to account for our x to the fifth. We're going to put a 0. X to the fourth, it's not there, but we're still going to account for that. We're going to put a 0. Then we're going to have a negative 5. Now there is no x squared, so we'll put a 0. There is no x, so we'll put a 0. But there is a constant, so we'll put a negative 2. So this represents my x to the fifth, x to the fourth. Even though it's not in the polynomial, it would be in there with a 0 term, so I do have to still account for that. Now I'm ready to start doing my synthetic division. I'll bring a 4, 4, 4, 4, 4. Okay, 1 times 4 is still 4. Add that together, we get negative 1, negative 1, negative 1, negative 1. It's kind of weird because I get a negative, or I have a 1 here, so 1 times negative 1 then is going to be negative 1. Add them together. That's going to make a negative 3 at the end. So I should have a remainder of negative 3 for my solution. All right. So if you have a 4x to the sixth minus 5x to the third minus 2, if you're missing pieces with synthetic division, you're going to add in those zeros. Brandon, go ahead. So the polynomial only has a 4x to the sixth, and then it goes minus 5x to the third. So we're going from the 6 to a 3. So even though it's not in the polynomial would be 4x to the sixth plus 0x to the fifth, because in standard form we'd have to account for all degrees, plus a 0x to the fourth minus 5x to the third. So if our polynomial skips like from a 6th degree term to a 3rd degree term, there is going to be x to the fifth and x to the fourth. Even though they're not there, they would be like a 0x to the fifth, because that's not going to change the problem at all. And then a 0x to the fourth, that would not change the problem. So when we're doing any division, we still have to account for those numbers still being there. So it's just like in long division, if I told you you have a number with a 1 in the thousandths place, and then you have a 1 in the ones place, well, I'm not talking about the number 11. If I have a number 1 in the thousandths place and a number 1 in the ones place, I have a 0 in the hundreds place and I have a 0 in the tens place. I still have to account for those values, even though I only told you have a 0 or a 1 in the thousandths place, a 1 in the ones place. So anytime we're missing degrees, we have to add 0 terms to account for those when we start doing our synthetic division. Right, and you'll see other ways to use the remainder theorem. You can kind of play around with that. Right now, we're really focusing on synthetic division, so I did it this way, but you'll see Delta Math, they'll have other methods of doing it. You can simply just input 1 into your function and get negative 3, or you can do, like I did, the slow way. Geez, they're making fun of me. The slow way, you can use synthetic division to solve it out as well. So kind of play around with that. You got 3 problems from that section to try, so see if you can get those 3 remainders correct. I will stick around if there's any other questions or anything else I can do for you. Otherwise, you guys are all free to go. You bet. I'll turn that on right now, and then you can go ahead and work on that.